Okay.
Miss Flies.
Yeah.
She's
Hey,
showing the video.
it's okay. Check it with the board. I have all of my work on the board too. Okay, guys, so I'm going over the Calculating Atomic Mass worksheet, questions 1 through 4, 5 and 6, where we have to actually reverse and solve for either the atomic mass of one of the isotopes or the percentage. We're going to do that next week. So this is 1 through 4 right now. Okay, so I'm going to read it and I'm going to fill it into basically my unknowns up here. So really it can go up to 4 isotopes, but really we won't get to that to the 4th one. But basically whenever I read something, I'm going to put that info where it says isotope 1, isotope 2, isotope 3, and then I'm going to fill it into the bracketed formula. Okay? So let's do question number 1. Calculate the atomic mass of carbon if the 2 common isotopes have masses of, okay, so ready? Isotope 1 was 12.000 AMU and a 98.89% abundance, and 13.003 AMU with a 1.11% abundance. Okay, so remember, all we have to do is change the percentages to decimals, moving the decimal over 2 times, and then we're ready to plug it in our formula. So ready? If I move the decimal over 1, 2, our new number is 0.9889. Okay, so it's 12.000 times 0.9889. Okay, change this percentage, move it over 2. So it becomes 0.0111. 13.001 times 0.0111. Okay, so this one only had 2 isotopes. Let's do that. Now, you could do this, put it down here, add it to this, but I'm going to do it all in one foul swoop on my calculator. So when I do that, I do my 12 times 0.9889 plus 13.001 times 0.0111. Go over there.
If I, do you mind if I go try to watch out my eye, whatever I got in here?
Keep the door open.
Alright. Where am I at? Alright.
I think he's talking to you.
Oop, I did it. My bad. It was 003. No wonder I knew that this wasn't the right answer. Hey, we can hear you in the video, so go over there. You go over to him.
He's not looking at me.
So we got 12 times 0.9889 plus 13.003 times 0.011. So what you get is 12.011133 AMU. That's just atomic mass units. Okay, now when I look at my periodic table and draw my box, I see for carbon, with my bad eyes, I see 6C 12.0108. Y'all, that is very, very close to it. I know it's correct when that atomic mass that is on my periodic table is very similar here. Okay, so that's question number 1. Let's do question number 2. Oops, wrong class. Okay, so question number 2 also gives us 2 isotopes. I'm going to do the same thing. I've got isotope number 1 info, isotope number 2 info. So ready? Calculate the atomic mass of nitrogen if the 2 common isotopes of nitrogen have masses of 14.003 AMU, 99.63% abundance, 15.000 AMU, okay, 0.37% abundance, okay? This is gonna be tricky. So First thing I have to do is change this percentage into a decimal. So I move it over 1, 2. So my new decimal is 0.9963. Not that percentage. Over here, what do I do? So remember, in front of a decimal places, there's infinite number of zeros. So if I need to move it over 2, 1, 2, so now it's 0.0037. Okay, let's put these in parentheses. So ready? 14.003 times 0.9963 plus isotope 2, 15,000 times 0.0037. Okay, I put that in my calculator. 14.003 times 0.9963 plus 15 times 0.0037. Okay, this one is 14.0066889 atomic mass units AMU. Okay, now remember on the periodic table, I'm drawing the box. So for nitrogen, you got 7N140067. So we got 7N14.0067. Wow, we are super close. Awesome. We know that that answer is correct. Okay, let's do question number 3. Okay, question number 3 has 3 isotopes, so it's going to get a little bit bigger. Calculate the atomic mass of oxygen if the 3 common isotopes for oxygen have masses of 15, so this is isotope 1, 0.995, 99.759%. Isotope 2 is 16.995, 0.037%. And isotope 3 is 17.999 at a 0.204%. Okay, so wow, you have isotopes that weigh 15.9, 16.9, 17.9. Remember, isotopes, the only thing that differs isn't the number of positive protons or negative electrons, it's the neutrons in the nucleus. It doesn't change the charge at all, it just changes the mass of the nucleus. Okay, let's change these percentages. Over 2, this becomes 0.99759. Cross that off. Over 2, this becomes 0.0037. Cross that off. Over 2, 0.00204. Cross that off. Okay, now let's put it in our formula. 15.995 times 0.99759 plus 16.995 times 0.00037 plus 17.999 times 0.00204. Okay, putting that in my handy dandy calculator. 15.995 times 0.99759 plus 16.995 times 0.00037 in bracket plus 17.999 times 0.00204 This gives me 15.999458816 AMU, atomic mass units. And when I look at the box for oxygen, it's 8 O oxygen, 15.9994. Wow. 9994, exactly that. So I know I'm right. Okay, last one, question number 4 has 4 of these. Wow. Okay. Yes, yeah, that's fine. Take the pass. Okay, this one is for sulfur. Okay, so we have isotope 1 is 31.972 at a 95% abundance. Isotope 2 is 32.971 at 0.76% abundance. Okay, isotope 3 is 33.967 at 4.22% abundance, and isotope 4 is 35.967 AMUs at 0.014% abundance. Okay, I could tell that some of these percentages are going to throw us off, so let's do them. Ready? Over 2, 1, 2, so this just becomes 0.95, easy peasy. Okay, over 2, 1, 2, this becomes 0.0076, good. 1, 2, 0.0422, 1, 2, 0.00014. Okay. Okay, I think we've done this enough to where you know what I have to do. Multiply the mass times the percentage. So let's do it. Okay, ready? 31.972 times 0.95 end bracket plus bracket 32.971 times 0.0076 end bracket plus bracket 33.967 times 0.0422 end bracket plus. Make it even more. Yeah. Hey, they're doing great on the new calculators. Say thank you to Miss Blaylock.
Thank you.
Thank you for giving us poor chemistry students calculators that actually work. 35.967 times 0.00014 end bracket. Okay, that was a lot. Here's our end answer for these 4. 32.06242238. Yes, do all of the numbers. AMU. Let's compare it to sulfur's periodic table. 16S 32066. 16S 32.066. 066. So close. Okay, so if you need any help, let me know. This is the first 4 questions on the first practice. I'm about to post our 2 extra questions from practice number 2.